So we talked about the physical joins of data. Anytime you take data and have to move it back and forth between nodes and join it up, it's probably going to be fairly expensive. And there's three physical ways that Redshift does that. The hash, like we explained, is where it gives it a unique value, something easier to manage in memory, and then lines up those rows anytime you have the same hash. It's a very effective, pretty high-performant way to do it. Now, a merge join is usually quite fast because what a merge join does is it takes two data sets, it leaves the values the way they are, and it just merges them together. The trick is they have to be in the exact same sort order for it to be able to do this. Typically, this is a very fast way to join data, so when you see merge joins happening naturally, that's usually a good sign. Although I have pretty good experience with hash joins as well. Now, the one that you're going to want to keep an eye out for is nested loops. What a nested loop is it takes each row in one data set and then it scans another data set looking for matches. This is one of those exponentially impacting performance hits that you really want to avoid. Now, a good way to see this happen in the wild is let's do a cross join. Remember I told you to avoid cross joins because they create exponential work? So I'll just do dim product cross join to dim customer and ask it to explain that. And see, now we get two alerts. First, it says, hey, you're missing statistics on dim customer. But then also down here it says, hey, there's a nested loop join in this query plan. You should be taking a look at your join predicates. In other words, are you really sure you want to do a Cartesian join on these two tables? Now, from time to time, you will see a nested loop, and it's really the only way to get the data that you need. But this is one of those red flag items that you should be looking for. Now, for this last one, we're going to use a view. We created this view in the last course that we did, that building your first Redshift data warehouse. I like this view because it has quite a lot of logic in it. It uses a common table expression with some group bys. It has a windowing clause by getting an end tile. Real quickly, I'm going to format this query so it's just a little bit easier to read. I'll fast forward through this. But essentially what I'm doing is looking for my products that sell the best month over month. When we do the explain, we see some steps that we haven't seen before. First of all, you see some sorting that the query has to do itself. This is for that windowing function. As you can see here, it has to sort by the average unit price. Now, sorts can be pretty expensive if it doesn't align with a natural sort key. So if you have a slow running query, and you see a sort step that doesn't align with your sort key, that gives you something you could work on. Potentially, you could get a lot better performance out of that query by making sure what it has to sort on is already sorted on disk. Now, the other thing I'd like to point out about this query is look at this hash join right here. Notice that it says distribution all none. What that means is I'm using a dist key all clause on this table, so it doesn't have to do any data redistribution. That's what the none implies. So this could be good if this query gets used all the time. Now this right here is something we haven't seen yet, a send to slice. What this is doing is it takes all of that data, all of these steps that happened prior to it, so from the bottom up to that send to slice, it puts that all into a single result set and then sends it across the network, you see that next step here, and gives it to slice 0. So why is that interesting? Well, it's interesting because by doing that, we now know that slice 0 is doing the rest of the work. What this is the windowing clause. We've now reached the point where this query can no longer be parallel and one slice has to do all of the work to find my top products month over month. It makes sense because the nodes don't intrinsically know what the other nodes are doing. They can go gather data, put it in a specific order, and return it. But when I get to this level of logic, that has to be done by a single node. Sometimes you'll see this same thing where it says send to leader node, and that would be for the exact same reason. So what do you want to keep in mind here? Well, how much data am I sending across that network? Is there any way I could send less data across the network and get the same result that I'm looking for? Those are the types of things you want to ask yourself. But as you tune queries and you go through the steps to understand physically what is happening on disk, these query plans will become more and more useful to you. And you'll get to the point where reading them kind of becomes second nature, and right away you'll pick up on things that say, you know what, that is probably something that could be done in a much better way. In the module on monitoring, we're going to find a lot more information that you can also use to dig into these query plans.